In this video we will explore other variations of v function by changing the sign of imaginary parts involved in the function. Let's recall what v function is from previous video. It's a combination of four Riemann zeta function as shown in the diagram. V function contains several math concepts, namely natural logarithm, Riemann's zeta function, Euler's number, distance from the critical line, and imaginary number. In this picture, all imaginary part of zeta function have positive sign. The plot result is a curve like the letter V with rounded corner as the real part. Now we show some variations of those signs which turned out to produce the same curve as the real part of the plot. The combination pattern here is that the left signs are the same as the right ones. Another type of curve is produced with a specific combination pattern of imaginary signs. Here, the left signs are the opposite of the right ones. The real part of the plot is similar to previous plot, except that the rounded corner is pinched down to 0. The imaginary parts of the plot may look discontinuous in the bottom plots. But we need to remember that in complex logarithmic function, the imaginary part represents the angular position. In this case, positive pi and negative pi point out at the same direction. Thus, they are not really discontinuous. This is yet another type of curve, which is similar to y function as described in an earlier video. The shape of the real part is basically similar to first type of v function, but the corner is pulled to negative infinity. Whereas for the imaginary part of the plot, the difference between the left and right side of the vertical axis is pi, which means it points out to the opposite direction. Hence indeed, the imaginary part of the plot is discontinuous. Here, the numerators have the same signs while the denominators have the opposite signs. This is the fourth type of the curve, which is basically similar to first type of v function, but the corner is pulled to positive infinity. Just like in type 3, the imaginary part of the plot in type 4 is also discontinuous. Here, the numerators have the opposite signs while the denominators have the same signs. With more patterns we know about combinations of Riemann's zeta function, we get more chance to cross-check one result against another, which might lead to contradictions that can be used to prove Riemann's hypothesis. Thanks for watching.